What's going on, fellas? This video is for my friends over at M&M Mining. I'm going to show them how easy this burner is to light. This shorter combustion nozzle is far better suited for diesel. It doesn't choke itself out. And I just want to go over a couple of things. So we're going to go for a little walk here and look at what this thing can do and how much easier it is to light than the 20mm version of this silicon carbide burner. As you can see, the flame output is far more suitable for the application we intend to implement with these things, so this should do a lot better. These are also fairly wind resistant burners, and I wanted to point out the effects of running these burners in a confined space. There's definitely some dialing in that needs to be done. You can see here the output of this thing is pretty incredible. We are in the 240 kilowatt range right there. I believe that's like 500,000 BTUs. I'll have to double check that. Here's a little test of me lighting it up inside of a confined space to show you that it's also very easy to do. Not any problems at all, but I want to show you what can happen when entrained flow takes place in that flame. Entrained flow is when exhaust gases from the flame start to get back into the combustion. It can diminish the performance of the flame. Okay, you see here when I got this flame turned all the way up, it has no problem. It could care less. I'm gonna do it one more time. Because we have the flame or the burner outside of the combustion chamber, we're getting secondary air in there. So it's eliminating that entrained flow on the very front of the nozzle. Fresh air is occupying that space because we've caused a Ventura effect. Now you see when I put that burner back inside there, it struggles. It doesn't like it. I'm not adjusting the fuel, fellas. I'm simply repositioning the burner to show you guys that there's something called standoff that we need to take into consideration, and we may need to implement standoff on this design. You see how far more effective the burner is with that secondary air? So we may take some all thread that's like 1 foot long, stick it in the holes that we currently have the burners mounted to, and then use some bolts to stand that burner about this far off of the drying chamber, because the performance with that standoff is far better. I can't stress enough the need to test things like this. We're basically doing research and development here on this particular box, guys. I mean, the interior of your box is going to cause all kinds of different turbulence that needs to be addressed. And I believe that standoff is going to solve that problem. You can see here, this thing could care less what I'm doing to it. It's not going out. I can easily make this thing go out if I push that burner all the way into the confined space. So if we just made a little hood to cover this thing up, keep the rain off of it, and maybe a little windshield. It might not even need a windshield, but you don't want it blowing out when you got your head turned on you. So just a couple pieces of sheet metal. But look at that. I can turn the thing up to about 500 kilowatts there. It hates it when I put it inside of there though. Now we've got like a fuel fire on the floor. So just wanted to show you guys that. Essentially a abstract diagram of the bypass flow setup. Essentially the way this thing works is when we go to prime the system, we're going to want to close the bypass valve. That's the valve that's connected to the intake of the pressure washer pump. We close that valve until we know we have fluid flow. We're going to want to find some way of indicating fluid flow. And you can do that by opening up the purge valve until you start to see fluid flow out of that. As soon as you see fluid start to flow out of the purge valve, you close it. Then you open up this valve just a little bit. Now that it's primed, it should start to pump oil. Now, during that process, the flow valve has to be opened, and one of the valves on one of the burners at a minimum has to be open, because as this thing tries to siphon, as it tries to prime itself, it's going to start pumping air. And if we have this valve open when we start that, it's going to pump air in a circle. And the system will not primed, and you'll be sitting there scratching your head. So we close that valve. It then pumps air through this section here. The air will travel through here, out the system, and out one of the nozzles in the burner. So we got to have this valve open for that to happen, so that when we close this valve, the pumping action doesn't start. Then once you know you've got fluid flowing, you can begin to pressurize the pressure cavity, which is basically just this loop of hose. The more we close this valve, the more pressure is going to build up inside of this air accumulator, which pretty much just balances out pulsations from the pump to give us stable burn. So we will slowly adjust this nozzle, and we'll also be opening this nozzle in tandem, kind of dancing these valves until we get the pressure that we want. We're going to want to go with at least 100 psi's inside this air chamber. That should give us plenty of pressure to lift the fluid up to the burners and get everything working right. But once you start messing with the burners, you're then going to have to adjust this flow valve again, and possibly this valve again, to maintain that pressure, because every time we make a change, that needle's going to move on us. So it does take a little bit of adjusting, but once you get it running, you're good to go. And I hope that describes some of the things that were kind of troubling you guys a little bit. That's basically what we're looking at. We also would want to drain this on occasion if we notice that the fuel is pulsating a lot. Sometimes this air column will dissolve into the fuel and eventually disappear. So periodically, when we purge the system, when we open that valve to prime the pump, that should solve that problem. So we shouldn't have any problems with all that air going out of there. But for the most part, this valve here is to discharge to the manifold or the burners. Since we're hooking up several burners, we're going to be hooking this up to a T section or some type of manifold. So I hope that sheds a little bit more light on the process. I'm going to post this information and get it to you guys as soon as possible.